and then we'll have a little more informal discussion if there's enough interest afterwards. So, Steffi?
Thank you, Jim. Carl, would you like to introduce yourself?
Sure. Thank you, Steffi. As Jim said, my name is Carl Ulibarri. I am a semi-retired general contractor here in New Mexico. I have quite a long background in contracting, electrical, manufactured housing, and distribution was my latest endeavor before I semi-retired. So I opened up a consulting company, NM Home Solutions, and I am now working as a subject matter expert consultant in this green energy space.
He's awesome. I'm Steffi Weisword. I am with 350 New Mexico, and I'm also a Rewiring America Electric coach. And Carl and I advised a few homeowners, several homeowners this summer in the Albuquerque metro area, including the East Mountains, and people who wanted to upgrade their HVAC and install heat pumps. And later in this talk, we will share some of these observations in hopes that it'll help you overcome some of these barriers. I didn't try to, why isn't this? Oh, so this is just an overview of the talk, why people want to weatherize and go electric, a little bit on heat pump basics, and then Carl will start talking about some of our 4 lessons that we learned. There'll be time for questions. And in the chat, there will be a link to a handout, and also the slides and video will be available on our website and sent to all those who registered. So why should we weatherize and go electric? If you're feeling overwhelmed by the climate crisis, I know I am, this is finally something we can all do that will really make an important impact. You've probably heard that methane, which is the primary ingredient of natural gas, is at all-time highs from the last 800,000 years, even though governments have set this as a low-hanging fruit to get rid of and reduce. So getting gas out of your house will really help a lot, not just for the climate though. It will improve your quality of life. Not burning fossil fuels in your house will make your indoor air better, and replacing the gas with electric equipment and appliances which have unprecedented efficiency will lower, if you weatherize, will lower your energy use and probably end your bills, particularly if you have propane like we do, or electric heating. And these appliances also have state-of-the-art control, precise control over whatever you're doing, whether it's cooking or warming your house or heating your water. And they're just fun to, if you've ever tried an induction cooktop, they're really fun. Of course, the other reason is, as Jim mentioned, there are a lot of incentives to help you from the Inflation Reduction Act at the federal level for tax credits. The state now has this new website to help you see what programs they're going to have, and then your electricity provider may also have rebates, and these can be combined and stacked for greater savings. Okay, for heat pumps, for those of you who are not very familiar with heat pumps, there's one already in your house. It's your refrigerator. And if you've ever stood in front of it, if it's venting out to the front or in the back, you'll feel heat coming out of it. Well, that's a heat pump that is gathering the heat inside your refrigerator and then venting it into your kitchen. Heat pumps for your whole house can do 2 things. It can move the heat so that it cools and heats your house depending on the season. And because it doesn't use any energy to create heat, like when you burn gas, for example, it just captures it and moves it. Heat pumps are 4 to 5 times more efficient than your traditional HVAC. The pictures here show what's called an air source heat pump because they're getting the heat from the air, but you can also have a ground source heat pump or even a water source heat pump for where you're collecting the heat to move. If you already have ducts in your house, you probably would get a central unit that will just replace either your AC or your furnace and work through there. But if you don't have ducts, or if you have a room that needs supplemental heating or cooling, or you're putting on an addition and you don't want to pay to have a gas line in there, mini splits are the way to go. And actually, you can combine them. They're very versatile depending on what your home configuration is. There are also window heat pumps that just plug in to a regular outlet, and those are great for both homeowners and renters. If you haven't experienced living with the heat pump, it's a different sort of philosophy and experience. So when you have a gas furnace, and typically installers will oversize their gas furnace because they don't want to have to come back to your house if you're complaining about not enough heat. And that furnace will just blast on and off, and you'll know when it's working. A heat pump is very different. It's a lot more subtle. It's more like a feather. It will make tiny little adjustments to the temperature, and you may not hear it at all. As I said before, if you can lower your total energy bill, especially if you're on propane or electricity. If you go from gas to heat pumps, your electricity bill went up. That's what happened to us, but our overall energy bill went down. As far as natural gas goes, on our website at 350 Electrified Part, there is a calculator buried deep in all the information about how you can calculate what the operational cost would be if you have natural gas now and moved to a heat pump. But make sure you include all of the fees that you get in your gas bill. Finally, the refrigerants are about to change in heat pumps next year. And so installers are now trying to get rid of their existing inventory. And it's not necessarily a bad thing to get that equipment, but it's a good idea to ask your installer if you're getting the most up-to-date model that they have available. When you get a proposal from an installer, you might see these words on it: single stage, two stage, and variable capacity. They essentially reflect the efficiency of the heat pump. The single stage and two stage are the older technology, and they're kind of what gave heat pumps a bad rap to a lot of installers who think heat pumps don't work in cold climates. These were really used a lot in the Southeast. However, Carl and I were seeing a lot of these installed this summer, coupled with 80% furnaces, which is not very efficient, but he'll discuss that more when he talks about dual fuel. That's when you have a heat pump and some other heat with it, like gas or even electric, but dual fuel we're going to talk about is all gas. So the last one, the variable capacity, or having inverter technology, this is the newest tech, and there's a whole group of heat pumps class called cold climate heat pumps, and Carl is going to tell you about those.
Thank you, Steffi. So before I go on about the heat pumps, I just wanted to emphasize a couple other things and highlight some stuff about what you already explained. With heat pumps, you technically are going to feel a range of heat that's more consistent and even, instead of feeling that blast of heat from a gas furnace when it comes on. As Steffi mentioned, you feel it. You can put your hand by the register. They're either on the ceiling or the floorboards, and you can feel it. You can like, man, that's nice and warm. With the heat pump, if you decide to go that way, I encourage you not to be disappointed that heat pumps will tend to run a little more frequently, but they're actually using less energy. And what they're doing is maintaining temperature over the duration. Instead of going hot, cold, they kind of run at a consistent temperature. And a lot of homeowners that have received heat pumps think it's like, oh my God, this thing runs 24/7. It's constantly running, but it's running at a very low energy consumption and keeping a steady state of heat. And it's going to be more lukewarm to the touch. So you won't feel that heat as you put your hand near the vent, but it'll be warm. And trust your thermostat. If your thermostat says, 72, 73, whatever you like it at, trust it's going to maintain that temperature. So just wanted to point that out before we go too much further. But anyway, as Steffi mentioned, cold climate heat pumps are the newest technology, and they're not even that new. They've been in existence for several years already. And you might have heard about heat pumps in general from other people outside of New Mexico. We typically have not had heat pump usage here in New Mexico, in our part of the country at all, in history, because they just have never worked well in this climate. But back east, they've been using heat pumps for a lot of years. And the traditional state of heat pumps that Steffi mentioned in the prior slide, they will typically only work well to about 35 degrees. And then they start diminishing, they start failing after that, because they can only extract so much heat out of the atmosphere to move it into the home. Cold climate heat pumps, however, with the newest technology, they can work at down to 0 and below, depending on how expensive a technology heat pump you buy. They can actually get down to 0 and keep on producing heat. It's amazing. Looking at the graphic right there, you see the snow mountained up on top of that heat pump that's on the outside of the home. But it's pretty remarkable the heat that can be produced out of cold weather outside and moving it to the inside of the house. So yes, typically a cold climate heat pump can cover about 99% of the heat that's required for your home. And you would just need a backup source of heat in the event it got down below the capacity of that heat pump. And backup heat is a couple of terms that they use. They're emergency heat, supplemental heat, backup heat. And those are usually in the form of electric resistance heat strips. And those are like what you see in a toaster, right? Those glowing little coils. Those use up a lot of electricity. But you can also have dual fuel, meaning you would have a gas furnace tied together with your heat pump, and that would kick in when the heat pump is no longer able to sustain. Space heaters, wood stove, you can even throw on an extra blanket if it gets that cold for 1 or 2 nights out of the entire year, that you would have that scenario. But we have friends in Colorado that are using cold climate heat pumps with no backup heat at all, and they're perfectly comfortable in that climate. So they work, and they're proven technologies. So next slide. So as we start looking at weatherizing your home, the term weatherization just kind of means doing an audit of your home, and then weatherizing that home in the form of either sealing what they call the envelope, and that could mean sealing all the gaps and crevices in your home that are bleeding air. You can see on the graphic where the heat moves in from the bottom and
Sorry, Carl.
goes up, goes to the top. So, but yeah, so that's always the first step. That is the preferable step, is you hire somebody to perform an energy audit on your house. And that audit is going to be a comprehensive set of tests on your house that are going to determine where your leakage is coming from, if you need more, if you could benefit from more insulation, and your electric panel, your fuel systems. It's going to analyze all of the current things that are in your house and make a determination what are the best sources for spending your money the most effective way. Next slide. So here you can see a graphic of the cold air coming in, heat rising out. You lose heat going up through the attic if you don't have enough insulation up there. Any gaps, cracks, below your door threshold, around your door perimeter, your windows, pipe vents, anything like that where the air can escape, you're losing your efficiency out of your home by trying to make that system work harder just to keep the heat or even the cool in the summertime. It works both ways. So that helps lower your energy bills, lower your cost of the size of the heat pump that you would require. It could help lower your need for a panel upgrade if you're not having to put as big of a heat pump that might be thought you might need but don't actually need. And it'll keep your home more comfortable. And that'll be keeping the allergens and all of the contaminants from outside from coming in your home. And yeah, overall be more comfortable with your state of living. So an energy audit. So the energy audit, the primary function of that audit is a blower door test. And what that does, if you can see the gray graphic in the upper right-hand corner, that would be like your front door. And what they do is they attach this apparatus to your door with the door open and put this system on there, and it creates a negative pressure in your house. It's basically blowing air out. And it has an electronic device that's calculating the resistance on that fan and determining how much leakage you have in your house. And there's parameters that they go by to make all that determination. And then they can further calculate your leakage. They go around testing the house with it's like a bucket kind of thing. And they can put it around your various vents and your light fixtures and your floor vents. And they can calculate exactly where the leakage is happening just by going around and putting that bucket thing in the various points that they are familiar with, that they know where leakage happens. They also use a thermal camera, and that thermal camera can determine heat and cool. So they can point it at your walls and your windows and your ceiling, your attic. It can look at all kinds of different places in and around your house and determine where heat or cool is escaping in or out of the house. So they can further pinpoint the areas that need checking up on. And that's what they call examining the envelope of your house. So that's basically the tightness of your entire footprint of your house. And again, they go through looking for leaks and the actions to mitigate those problems. Through that energy audit process, they can also do an energy load, which is often referred to as a manual J, to determine that if you do all these measures that it's requesting that you do, it's going to come out with the size of an HVAC unit that you could get by with. Typically, contractors don't do that very often. They kind of go off of a rule of thumb method. Sometimes they'll do a manual J, but they don't feel comfortable with the outcome, so they'll increase it just so they don't have the callbacks that Stephanie was referring to. So that's a very important calculator that is a part of the process of the energy audit. And then they do a duct inspection. So that is what they call a manual D. And that is just to determine the capacity of your duct system, if it can have enough supply air, enough return air to make that system run in its optimal state. Energy audits can run anywhere between $600 for a small house with very minimal angles and pitches and things like that, to as much as $1,200 for a very large, let's say 2-story house, 3,000 square feet or something like that, because there's just more work to do in that house and more things to look at. There is a tax credit for 30% of the cost of that energy audit, up to $150. So you can't get more than $150, and it's not a lot to offset that cost of $600 to $1,200, but it does help. If you can't afford the full-on energy audit, PNM here in Albuquerque and the surrounding area does offer a home energy checkup program. It's not as comprehensive as a full energy audit, but they do have that process in place. So if you can't afford an energy audit, we do suggest you at least try to get PNM's home checkup. So accurate load calculation, that's very important. Steffi and I dealt with some consumers, some homeowners, on some quotes that they're receiving from various contractors. And this one in particular, she had an 1,800 square foot house. The installer claims he did a manual J and determined that she needed 72,000 BTUs of heat. Even though her old furnace that was pre-existing in the house was only 72,000 BTUs, and it was probably only a 70% efficient furnace, he was telling her, trying to convince her that she needed a 72,000 BTU gas furnace. So Steffi and I and her husband used a couple of free software pieces. One of them is called CoolCalc, and we entered what we knew about the house. Steffi and her husband visited the homeowner and gathered some information. And we estimated, based on that software, that she only needed 45,630 BTUs for her home. So you can see the huge difference in the size of the potential heat pump that he was going to put into her house that was completely unnecessary. And that's even without performing the energy audit. That's just looking at what she had existing in the home, right? Her existing windows and what we knew about the insulation and the structure of the house. And the recommendation after the potential air sealing measures and window coverings and other items in there, it turns out that she could get by with as little as 34,421 BTUs. So that's taking it down to the very, very nitty gritty, but you can see the huge variance in what contractors are trying to convince customers that they need versus what they truly can get by with. So that's one thing to really get some help and do a lot of research on before you commit to a very expensive conversion on your house. So the weatherization examples, there's for tax credits. There's a federal Inflation Reduction Act tax credit where you can get up to $1,200 per year, and that includes window and film treatments. In New Mexico, you can get $1,000 to $2,000 for insulation and $500 to $1,000 per window. I believe that's for replacement windows, correct, Steffi? Yeah. And then for the rebates, the energy rebates, EPA windows, cool roofs, insulation, and other measures. New Mexico Gas, you can get $1,200 for insulation. PNM will provide $80 per window, and they have some other rebates for other sealing materials that you can get as well. And those are discounts, I think, at the register, I believe, like at Home Depot and Lowe's. And so far, New Mexico, the IRA first stage of the HEAR rebate is up to $1,600 discount on DIY insulation that you can buy directly from the store, and you'll get that instant rebate directly at the counter. You do have to pre-qualify and go to the clean.energy.nm.gov website to determine your eligibility for that, but that can be an instant rebate if you're able to install insulation on your own. Next slide. So some of the low-hanging fruit, if a lot of these measures, if you're not ready to do those just yet, it does take some money to get there. And if you're not there just yet, there are some things that you can do yourself that are relatively inexpensive. One of the key things you can do is LED light bulbs. Those all have rebates that are calculated directly at the register via discounts. And those can save you quite a bit of electricity if you're still using incandescent bulbs. Tubes of caulking are relatively cheap. You can look around your doors and window frames and any other protrusions in your walls and seal up those gaps with caulking. Weather strips, door sweeps, those are all very easy to install and very DIY friendly. Spray foam around your open crevices. That's like, installing the caulking, but if you have larger gaps, you'll want to use spray foam. And you can spray that around any pipes that are coming through the floor or the walls or the ceiling, any conduits. Coincidentally, Stephanie and I were talking about this, can lights. If you have any can lights, like in your kitchen or sometimes you have them in your living room, a lot of times if they're older can lights, those are open into the attic. There's free air running through those canister lights, going right up and out. You're bleeding like all your heat right up through the ceiling and it's going right outside. So they do sell some little baffles you can put in there if you don't want to replace the light fixture, or all the new LED can lights are sealed systems so that you don't bleed the air out into the attic. So if you want to go that route, or you can buy these little cones that you can stick behind the bulbs that'll block the airflow going out into the attic. Smart thermostats are also a good resource to put in your system. That'll help if you utilize the energy function in the smart thermostat. It helps. If you keep cranking up the thermostat to get more comfortable, then doesn't do you a lot of good. But you can use the smart capabilities on the thermostats, and those are proven to save energy.
So now I'm going to tell you about our second thing we learned. And if you want all the incentives, you're going to have to do your due diligence beforehand. There's all these great incentives, but there's a lot of fine print. And whether you qualify may depend on your income, how many people live in your house, where your house is located, whether you pay taxes or not. And then your equipment may or may not be eligible for all these great incentives. Unfortunately, your installer is not the best source of information for this, and I'll show you in this example that we have. A homeowner called me from Rio Rancho. He called me while his installer was just finishing up and had given him the invoice. And he wanted to know, because he pays taxes, he wanted to get the tax credits. And you can see from the invoice, it said dual fuel, most efficient, environmentally friendly, energy efficient home, improvement credit 30% up to 2,000. And that's referring to the Inflation Reduction Act tax credit for heat pumps. He got this installer from P&M's list of trained midstream installers through that program. P&M actually has 2 programs for heat pumps. The other one you get through the checkup program. And he installed a 96% furnace and a heat pump. And so let's look and see what kinds of things he could have gotten. Very convenient on the invoice, they already take out the rebates. So he had already gotten $325 because of his furnace, which is called a tier 2 furnace. It was 96% efficient. Unfortunately, if they'd gone up by 1%, they would have gotten a little bit more of a rebate, but $325 is fine. Through the midstream program, he also got $540 off of his invoice, which was nice. If he had put in the most efficient heat pumps, he could have gotten up to $860 on that one, but that's okay. So let's see, he wanted the tax credit, the federal tax credit for the furnace, which is 30% up to $600, but it requires a 97% efficient furnace, so he's not going to get that. What about the state? They give $1,000 for a heat pump if you're not low income. Low income is $2,000, but dual fuel is not covered by the state. They want to encourage all electrification, so they are not supporting dual fuel in either their rebates or their tax credits. Finally, the city of Rio Rancho had a $1,500 incentive for switching from a swamp cooler to a heat pump or an air conditioner, but neither he nor his installer knew about it, and it needed to be pre-authorized, so he missed out on that too. Finally, here, the IRS federal credit for the heat pump, which is what the invoice talked about, up to $2,000. Would have been nice, but the installer did not check the entire dual fuel system in a particular website, and he did not give him a certificate. So he could have gotten $6,000 in incentives, but he only got $865. This is what part of what a certificate looks like. And you can see at the very top that it says possibly IRA. I can't see because of
potential eligibility.
Thank you. Yeah. And so it would be great if you're in this situation to ask your installer for this certificate. And for the federal tax credit, I've been told they're not very strict, and you keep what other documentation you have. It's just if you don't file it. So if you were audited, then it would be a problem. But a lot of the co-ops want this certificate, and the state wants good documentation that your whole system qualifies as Energy Star and for the IRA. So don't assume that if you're getting equipment through a utility and getting rebates for it, that it will also qualify for all these other things. And remember, there are no New Mexico incentives for dual fuel systems. Carl?
Okay, so we're going to talk a little bit about electric panels. So during our many discussions with homeowners, the topic of installing a heat pump was going to put an added load onto the house, and if they had enough capacity in their main breaker panel. So on the picture on the right, this is an image of what you would typically see on the inside or the outside of your house. It's your main circuit panel where all of your breakers are for all the various appliances and lighting and such in your house. The very top breaker is usually where your main breaker is located. In this example, this is a 100 amp main panel that is in this particular customer's house. And she wanted to add a heat pump, and a heat pump was going to add probably a minimum of 30 amps to this load. And you can see also on this particular image, there are no available slots for any other devices either. So that's usually a problem. So doing a panel upgrade could cost as much as $4,000 or more, and it could cost as much as $30,000 to upgrade to a 200 amp service if your utility provider deems that your transformer or the conductors coming from the transformer to your house are not up to capacity. And so it's not even just the cost of the panel itself, it's everything behind it all the way to the utility provider's end of it that could cause a huge cost burden to you as a homeowner. So in this graphic here, you can see if you have a really older home, a lot of those older homes only had 60 amp main panels. If that's what you have, you're most definitely going to need a panel upgrade. And that's going to just be a reality of what you're going to have to do. And most of the time when you do that, they'll just upgrade you to 200 amps. That's usually the default for any current homes that are built in today's world. If you have a 100 amp main panel, through some planning and working with your electrician, you could probably avoid getting a panel upgrade, and we'll go through that in another slide. And if you have 200 amps, there most likely will not be any upgrades needed unless you fully loaded out your panel, which would be pretty unheard of. So usually if you have a 200 amp panel, going the electrification route would not be a problem at all. And your electrician would be able to calculate any loads for you and to make that determination. Next slide. So is 100 amps enough power? For 99% of the households, it is. Hang on a second.
This comes from a study that Sean Armstrong and a number of people did at Redwood Energy and some other places. And because the way the electrician rules are, you have to wire for the possibility that you'll have every single appliance on at the same time, and that just doesn't happen. And so in reality, even if you have gas and electric or all electric, most all households use actually less than 80 at any one time.
Yep. And there's a process of doing a load calculation to make that determined. There's an official calculator that's put out by NEC, which is National Electric Code, that can make that determination for you. But Steffi is right. You're never using everything all at once. So there's a thought by homeowners or unexperienced people, if you calculate the load on all of your breakers, the number, like you have 20 amp, 20 amp, 15 amp, 15 amp, if you total all those up, that's going to be your max load. That's not the way it works. There's a complex calculator that makes assumptions on how much percentage of the appliance you're going to use at any given time of the day.
Also, another thing I'd like to add about that particular homeowner, because of Carl, we took off the panel and found there was 50 amps that weren't being used, and it wasn't labeled like that. So you really, heat pump installers are not usually electricians. So you might have to get a second opinion.
Absolutely, yeah. So a few thoughts on how you can save money. There are some other things you could do if you have a breaker panel that's at full capacity, or you're at 100 amps and you're not sure you can squeeze any more amperage. There's a couple of interesting devices that you can use. One of them is a smart switch. They have a apparatus that you could plug in typically where your dryer, almost every house has a 30 amp dryer receptacle, right? Everybody pretty much has a dryer these days. They have a device, a smart device that you could plug into the dryer receptacle, and it'll have two outlets on the outbound side, as you can see on the small graphic to your left, where you could plug your dryer in and then maybe an EV charger. And the smart charger will determine which way the power is going to be shared. They're never going to be operational at the same time, but you never dry and close all day long, and you're never charging your vehicle all day long. So that smart switch is a very inexpensive way to not have to make any major changes to your panel, and you can just plug that in. That picture in the upper left is a smart switch right there, and the black apparatus there is the charger to the right. So that's sharing a dryer plug with an EV charger. Another item is smart panels. They can be a little more expensive, but that if you are having issues with the transmission lines coming to your house and it's just not possible to upgrade, a smart panel can do kind of the same thing as that smart switch, is that all of the breakers in there are running on some technology that can help spread the load to the drawing appliances that need it the most at the specific times that they need it. But that can be very expensive. I believe the rebates do qualify, or the tax credits qualify for some of those upgrades. Adding a heat pump water heater, that's a pretty energy efficient upgrade that's very easy to install, and they have 120 volt variants of those heat pump water heaters, and those are will actually run on a regular plug-in circuit that's not even a dedicated circuit. They're that energy efficient that you could just plug and play those things, and it'll actually provide the hot water that you need. Still, I advise getting a plumber to do that for you, but yeah, very easy way of saving energy. And then you have your 120 volt cooktops, your induction cooktops. Steffi has one of those. I understand she likes it very much. So there are other things you can do. We have a link to Sean's website where he talks about the Watt diet. So some interesting reading material there where you can learn about saving the consumption of your electricity and being able to share it and spread that out a little more efficiently if you're going to try to get to a heat pump.
So you don't have to have a panel upgrade.
So you don't have to get the panel upgrade, correct. All right, next we're going on to dual fuel. So dual fuel is basically incorporating both technologies. You're going to keep an existing gas furnace and you're going to couple it with a heat pump. So the heat pump is the apparatus that you typically see on the outside of the house. It looks very similar to a refrigerated air unit. And then you're going to incorporate that with an evaporator coil that'll sit either on top or below the furnace, depending on if you have upflow or downflow. So it's a heat pump with the gas furnace incorporating both. And so for the first example, when we were talking about older heat pumps, those heat pumps would start diminishing in efficiency at 35 degrees. They just couldn't sustain, and they'd start dropping off. So typically the installers, if they're going to go this route and they're using one of those stage 1 or stage 2 heat pumps, they would set what they call the balance point on the thermostat to transfer the power to the furnace and away from the heat pump, say at 35 degrees. So your heat pump's going to stop, the gas furnace will kick in, and that's what's going to start keeping up the maintenance of your heat when it's getting below 35 degrees outside. If you're going to go this route, it's probably best if you can get it for the climate. It's best if you can get a 95% efficient furnace to reduce the emissions and get the tax credit. But it's hard to find a qualified matching system that'll meet that AHRI certificate that Steffi was talking about. This is just some weather data just for the city of Albuquerque. On the bottom, you see that's where the outdoor temperature is, and then the BTU capacity to get to that temperature will be on the left vertical column. So you can see at 35 degrees in the center highest point, you're going to need about 28,000 BTUs to maintain that heat for that temperature.
And this diagram also it's a proxy for the frequency of days that you get these different temperatures. So you see most of the time we spend around 35, and as you go off to the ends, those don't happen as often.
Yeah. And so for the brown line with dual fuel, warm climate, you're going to need that 30,000, close to 30,000 BTUs at 35 degrees. And as you go to the left, you're going to need more and more gas to maintain that heat as it gets colder. If you have a cold climate, high efficiency heat pump, you could get down to 10 or below with the efficiency of that heat pump running and saving the climate by doing that and not having that gas furnace running.
Sorry, my internet keeps stopping, and when I click to get back into it, it changes the slide. Yeah,
So
sorry.
a good question, a good tip is to ask the contractor if he's quoting you on a dual fuel system, what temperature is he going to set that supplemental heat at? And if he says 35 degrees, ask him why, and ask him, is this a cold climate heat pump you're quoting me? Because most of the time it's not. And part of the reason we've discovered too, is what Stephanie alluded to earlier, is that there's a lot of existing stock in warehouses from the distributors that are of the older type heat pumps. So they're trying to offload that before the end of the year, because cold climate heat pumps are starting to make their way into the market and starting to gain popularity. And then we have a refrigerant change that's happening at the same time. So we got a little bit of a perfect storm happening right now with the refrigerant and the supply chain. So there's not a lot of contractors out there willing or even able to quote cold climate heat pumps. And they're trying to convince the customer, even on a high SEER stage 2 heat pump, will still not do what a cold climate heat pump has the ability to do. So kind of ask those questions and make sure they're giving you what you need. Ask for that manual J, ask for that AHRI certificate, and make sure they're giving you what you're asking for if that's the route you want to go. So dual fuel, some of the pros, it's more familiar for these contractors, especially in New Mexico. It's what they've done for years. They just do a lot of gas heat. We've always been a gas heat kind of state, and that's what they're familiar with. And they don't like deviating from what they're familiar with for a variety of reasons. It's serviceability, just being familiar with the product that they do. You can have a lower one of the pros is you have a lower upfront cost going with the air conditioner and the 80% furnace. But again, if you care about the climate, those are some things in the right-hand column. Some of the cons, you're not going to get those financial incentives. If you're on propane fuel, you're absolutely going to be at a loss by doing that. If you're going comparing electric to natural gas, it's going to be a pretty debatable discussion on where you're going to save energy, but Steffi is a good case in point where you can save money if you do the envelope sealing and the smaller heat pump sizing and doing all these different measures. It can be beneficial. If you're on propane heat, or if you're currently an all electric house, you are absolutely going to save money by electrifying and going with the heat pump. As I mentioned, you're committing to 30 more years of fossil fuels if you go with a dual fuel system. If you're putting a gas furnace, you've got another 30-year commitment there. So keep that in mind if the climate is a concern for you. You're having more greenhouse gas emissions from your infrastructure. If a lot of people want to keep their existing gas furnace and just put in the cold climate heat pump, that can be okay if you have a relatively new furnace and you don't have the funds or the ability to change that out. However, if you've got an aged furnace and it works, and you think, well, there's nothing wrong with it, it works, I'll just put the cold climate heat pump on it. That's really a bad idea, because you have to do a lot of work by installing that evaporator coil on the furnace. And when that furnace does give out, and if it is a 20+ year appliance, a lot of times you can't find parts anymore, or it's going to not be feasible for you to repair that thing anymore. And you're going to have to undo the heat pump, remove the evaporator coil to replace that furnace. It's going to be a lot of double work and double the expense to do that. So think about that as you're going to make this investment, to not be tempted to keep your old gas furnace in the house and adding the heat pump to it, because it'll be more costly for you down the road. Then going back to the pros, you're getting state-of-the-art technology. You're getting an all-in-one heating and cooling appliance, right? So a lot of people, if you're currently running a evaporator cooler or a swamp cooler, this will do both for you. Or if you have no cooling at all in your house, and this will provide you heating and cooling by going to a heat pump. It's more environmentally friendly. If you have a nice tight envelope, the right size heat pump can be much smaller than you think you need without any backup, possibly. It'll be a personal choice. Higher efficiency means more savings over time as well. Some of the cons that it will increase your electric bill. However, it's going to reduce your gas bill. So it's a trade-off. And again, depending on the house, your scenario, all these things, it's variable on the savings that you're going to get. If you couple it with solar, you're absolutely going to be in the positive side of things of the equation. The hard part is gonna need to be finding an installer that is familiar with the heat pumps. We've talked to many customers and they're constantly trying to convince them to go the other direction and telling them that they're not good. They don't work in this climate. They absolutely do. The possible need for a panel upgrade, getting some electrical work done is another con that'll kind of increase some of the cost of doing that. But luckily, there are going to be some rebates and tax credits to help offset that. Next slide.
So your bonus lesson is electrification takes time, patience, and perseverance. Some of the people, all of the people I was working with, they were such warriors for sticking in there. I can't believe how long it takes, and it is difficult. So you need to know that first. And like Carl said, and this is from an article in Canary Media, most contractors, heat pumps take longer for the installers. They have to work harder for it, and they just don't. It's so much easier to just put in gas. So that's what they're doing. In case you're interested in more information, Electrify Now is a great website. They are having a upcoming webinar on September 25th, Wednesday. And the Ask Sean show is once a month. He talks about some homeowner he's helped, and they explain the decisions that they made for that house. Also, the Elders Climate Action, they have an Electrify Your Life series, which is really good. And then here are some other great websites that will help you. So this will be in the slides. You can look at it backward later. And now we will open for questions, although I think Carl had something to say. And I just wanted to say one more thing. I forgot to say at our house, we have a hydronic heat pumps, which actively cool and warm our house through a radiant floor system. So that's another form factor that you might consider.
I didn't have
and
anything.
Steffi, I had a couple of quick comments. This is Jim, your host. I also was or am an electrician and was an electrical contractor for years in the state of New Mexico. And I think the presentation was excellent. There were just a couple of quick comments I wanted to add and reinforce some of the things that Carl said. So absolutely the first thing you do is to increase the weatherization of your house. And depending on how old your house is, it's going to need more or less. So that means insulation, as Carl mentioned. But one thing that people forget about, because we talk about the walls and the ceiling, if possible, you want to insulate your floor. It makes an enormous, a surprising amount of difference. I did insulation on the ceiling and the walls, but it wasn't until I completely insulated my floor that the house really got tight. The other rule of thumb is that infiltration is the first thing you want to concentrate on. So that means the air blows in, and a real good day to tell about what's happening with infiltration is when it's cold outside and it's blowing like hell. Then you can go around the house, and Carl had a picture of an outlet that they were insulating around. You can put your hand up by the outlet. You can feel the cold air coming through, and likewise through a window or through a door. And that is, a tube of caulk is what, $6? It's the best $6 you'll ever spend. And so you want to really get your envelope in the best possible shape. And now there's even tax rebates on that. Um, the other thing is that once you get your, as Carl said, to reinforce that, once you get your house really tight, it's going to take smaller heat pump to heat it. Another approach to figure out what size heat pump you need is to look at your energy bill, your annual energy bill. So you can, if you're, no matter where you get your energy, propane, electricity, or natural gas, your energy provider can usually supply you 2 years worth of bills. Now, there is a little problem because if you have, let's say you have a gas furnace and you have a gas hot water heater, how do you tell what each one is using so you don't get the wrong size heat pump? So what you do is you look at your annual basis and then you subtract the middle of the summer gas bill because that will tell you what your just what your hot water use is. And so that way you can back out your hot water um, gas load, and what you'll have left is how many BTUs on an annual basis you're using, and that will help refine the number of what size heat pump. Um, and then one last quick thing is that um, Carl was talking about the uh, the whole question around whether your electrical service is adequate enough. And I was an electrician for a long time, and I know how some people think, and that is, it's called cover your ass, right? CYA. And so they'll just default to, well, you need, a 200 amp service when you don't really. So, um, one, there's two issues. One is the amperage size of your electrical service. And in general, we're all using much less electricity in our house than the house was originally designed to supply us. The electrical code has a fixed amount of electricity that guides the electrician uh, that built the house how much, what size service to put in. So that included incandescent light bulbs, um, less than uh, efficient appliances and stuff. So by going to LEDs and we're all going to more efficient refrigerators and dryers and everything else, our general baseline electrical load is getting smaller so that we have more headroom in our homes for new appliances like a heat pump. And the last issue is that in addition to the amount of electricity the panel or the size, the amperage size of the panel, there's the issue that Carl talked about some, which is just the physical real estate that you need to add some breakers. And there are several tricks that a good electrician has to get more real estate, breaker space in your panel. And one is to go to combo breakers. So most electrical panel manufacturers have a half-size breaker. It gives the same amount of electricity, but doesn't take a full width of a breaker. So you can double up those and create some empty spaces without really doing much at all. It's very easy. So anyhow, um, that's just a couple of things I had. And so, Steffi, are we ready for some questions?
We are.
Okay, Tom, have you looked? How are we doing with questions?
We have a few. Um, so I think I'm just going to repeat some that you may have covered in the materials, Steffi and Carl, but just in case, I'll just reiterate it. So one was, how do you tie in a gas furnace to heat pump? And I think you kind of talked about how to do that and the pluses and minuses, but maybe you can just quickly summarize that answer.
Yeah, so basically the furnace is going to be your air delivery system. It's what you probably already have in your house. And when you add refrigerated air or a heat pump, it's the same principle. You have what they call an evaporator coil, sometimes referred to as an A coil, that you sit on the top of the furnace or below the furnace, again, depending if you have upflow or downflow. And that's what collects the heat or the cool to distribute through the house. So it's just an add-on, if you will, to your existing furnace, if that makes sense. And then you have your heat pump, your appliance sits outside, and it's got two refrigerant lines that are piped into that evaporator coil that's sitting on the furnace.
So Carl, just a question. If it's in the summertime, and what you want to do is, distribute cool air, from your heat pump, how do you get the furnace to turn on its, fan system to distribute the cool air?
So that's all done through the smart thermostat, or even dumb thermostats will do it. So it's just a switching function in the thermostat that'll tell it to kick on the pump outside, and it's basically working in reverse. There's a reversing valve inside that heat pump, and it works in the opposite direction. Now it's extracting heat to the outside and bringing cool to the inside, and it tells the furnace blower to kick in until it reaches a desired temperature. So it's all done through just the wiring and switching within the thermostat.
Very good. Thank you. Francine had a question. Are there rebates from the IRA for an energy audit if it's a low-income homeowner that does not have tax liability?
I'll speak to that. So in New Mexico, the IRA rebates will be only for low-income people, and you can go to their website and click to see whether you qualify, either through their calculator or if you're already part of a specific like Social Security system. I don't remember the exact programs. For energy audits.
I don't think they've made that determination.
I don't think right now all they've done is insulation, and that's DIY. There is a second program coming out called HER, which will be performance-based, and that does require an energy audit, but we don't know yet how that program will play out. There is a tax credit of 30% up to $150, which isn't all that great, for if you pay taxes. And there's no energy audit state tax credit yet. If they're even, I guess that won't be a tax credit. I guess the only way it'll come through the state is through the rebates.
All right. I think a couple of quick ones. Lori asked about mini splits that she bought online and then had installed with a private contractor. Can I get rebates for the heat pumps?
I was just writing to her. I think it depends who the rebates would come from. P&M. If you want the rebates from P&M, if that's what your electricity provider is, I think you'd have to talk to them because they have their own rules. As far as the rebates for the IRA program that will be administered by New Mexico, I do not think they are retroactive. Do you, Carl?
I don't believe they're going to be able to retroactivate those, to my knowledge.
And they haven't even started that program yet. So they've just done insulation. They might add heat pumps by the end of the year, maybe. They have a newsletter, so it's great to sign up on that, and then you'll get all the updates that the state has.
All right, thank you. There was another one, and I think I know the answer to. Will I need to change out to the new refrigerant if you've installed a heat pump already with the old? I think not.
No, so the refrigerant is determined by the appliance time of manufacture. So if it's R410 is what's being used now, R410A, and if that appliance is, if that's what it was designed for, you don't change it. You can't switch between the different refrigerants. It's the new refrigerants that are manufactured after January 1 are going to be required to go to the newest, safest version of refrigerants that you cannot cross switch between them. So whatever your appliance is now, if that's what you have, that's what you stick with. They're not going to stop making the refrigerant, by the way. They're just going to stop allowing the manufacture of new appliances that utilize that type of refrigerant. So there's going to be some different compressors that are going to be designed to work with a different refrigerant.
Okay. Question, what is the typical warranty period for a cold climate heat pump?
It depends on the manufacturer, usually between 5 and 10 years for parts. The labor is usually determined by the installing contractor, which is typically 1 year. Sometimes they will load in an extended warranty and build it into the price. That's another trick that they kind of do to make more money. And it's like buying the extended warranty on anything, right? Sometimes you think it's worth it. Sometimes you wish you wouldn't have bought it. But the parts warranty is usually administered by the manufacturer, and it's usually anywhere between 5 and 10 years.
Okay. And you were mentioning earlier, Carl, that you know, a furnace can easily last 20 years or longer. Is that a decent assumption for a cold climate heat pump, that duration?
If maintained well, yeah.
Yeah, you have to clean the
Filters.
filters for one thing.
Very important to keep your filters clean.
And one other thing about heat pumps, bigger is not better. Bigger is going to give you a lot of problems. So that's another thing going against the psychology of current installers. It's better to be a little undersized than oversized.
Interesting. Okay.
Yeah,
Melissa
the way to
had,
think, just quickly, the way to think about that too is the most efficient, and this works in the commercial world a lot, is you want your equipment to basically run pretty much all the time. That's the most efficient. Turning off and turning on is very inefficient and doesn't really help the situation. Like Steffi said, if it's slamming off and on, it's probably oversized and it's not efficient.
got it. Thanks, Jim. Melissa had an interesting question, and then Ward, I'm going to get to yours. She said she's in a brand new development in Los Lunas, and was sad to learn the default for appliances was a natural gas range, heat, and hot water. Wonder if home buyers can have a role in advocating for more aggressive electrification adoption in new residential construction, and how can we organize them?
Absolutely.
Yeah.
Right now, I'm in Brooklyn, and starting next year, all new apartments, houses, everything have to have no gas, induction range, everything. So that's from political action, from building codes.
Is that like a city council ordinance that was passed, something like that?
Yeah.
No, it's the construction industry division in Santa Fe is the one that sets the building codes statewide. In New Mexico, we have statewide building codes, and so we've had battles before up there trying to get the latest efficiency codes, and it's a tough fight because the Home Builders Association doesn't want to do anything that adds a nickel to the cost of anybody's home, even if the payback is just a few years for the homeowner. They feel that they have all kinds of arguments, but we will have action up in Santa Fe when that comes up again, and we'll send out some emails so people can join us. That is definitely something that needs to be done.
Another thing, Carl and I talk a lot with the Go Electric group in Colorado, which is way ahead of us. And they really feel this is all has to be customer driven. They're working on the customers because the customer demands will affect what installers do. And then on the other side, Carl and other people are working on training for heat pump installers. So hopefully we'll be getting a better batch of them soon. There's going to be a cold climate heat pump class that he's arranged in Santa Fe Community College. So that would be great. Also, there's Energy Sage and Sealed are two organizations that create markets and vet installers, and they're in New Mexico for solar, but not for heat pumps. So if everybody gets and emails them and says, when are you coming to New Mexico, maybe we can get more action here.
Got it. Ward, you've been very patient raising your hand. You want to verbalize your question?
Yeah, I think what's been overlooked in this discussion is probably the simplest way for people to convert from gas and go electric is to put in a mini split, because you can buy one mini split for your living room area and wait another couple years and then buy one for your bedroom. And that's what we did. Our gas furnace, we had a gas radiant hot water heat system, and it was going out. And so we had a mini split put in our living room. And then a year or so later, we had one put in our bedroom. And then we had another one put in our daughter's bedroom. So it's the mini splits are a way for you to not have to put this whole upfront cost at one time. You can spread it over a number of years. And you can still use your furnace if you want to back up, but you'll find the mini split will heat and cool your house, and you'll get off the gas. And that's what we want, is you to get off the gas. That's the objective of this whole discussion. The other thing Jim brought up about the breaker space and the breaker panels, and if you go into Home Depot or Lowe's, they have a 20 amp double breaker, which is what you need for your mini split. And then they have on the side, so you take out two regular breakers, you put this one breaker with the 20 amp double breaker for your mini split, but it has on the side the two breakers that replace the breakers you took out. So you don't need any more space in your breaker box. It's a very easy, simple solution.
And you can actually buy heat pumps online that
Yes.
will be a lot cheaper than what your installer is going to charge you. And some of these are pre-charged with refrigerants, but technically, if you don't have a refrigeration certificate, you're not supposed to do it. So it's not terribly legal. So I don't know if you'd get any state incentives anyway.
The other thing is, you do it yourself is great. There's all kinds of skill levels, but the problem is if there's a problem. So you may think that you're getting charged a little bit too much by your contractor, but your contractor has experience in troubleshooting when there is a problem and will stand behind the product they've put in. If you buy it online, you have no recourse, and then you have to try to talk someone in to come in and fix your screw up, and sometimes that's a little bit hard. I don't know how Carl feels about going back in and there's well, we have all kinds of nasty names for do-it-yourselfers who
Yeah.
and then they want you to bail them out. And so there is a downside to getting it over your head. If you've done it before, that's great. I know Warren has done a bunch and done well, but there are some benefits to having a licensed contractor.
Absolutely. I always get a little cringy when we get into higher technology stuff, even electrical work with homeowners trying to do it yourself. There's all kinds of room there for fatal accidents, minor problems, things just, spending money and things just don't calculate out the way you thought they were going to happen. Even I was talking to Steffi earlier about state of New Mexico's first wave of rebates was going to be for insulation, and for the do-it-yourself homeowner, just go buy insulation. Well, there is a problem that can occur by adding too much insulation and blocking the cross ventilation in your attic space. And a homeowner might just think, I'm just going to jam as much insulation that'll fit. Well, you start blocking the natural airflow in your attic. Now you're going to start having mold and condensate issues up in your attic space. So even just doing something as simple as adding insulation could be a potential problem. Not so much here in New Mexico because we're pretty arid and dry, but if you get back east where you have a lot of moisture or down by the coastal areas and you do that and you block your airflow in the attic, that's going to create a huge problem for you by doing that if you don't know exactly what you're doing. So yeah, there's all kinds of things about doing it yourself. A lot of people don't have the money to hire a contractor, but at the same time, there's certain things that really should be done by a contractor. And I've heard a lot of other stories too about people buying those mini splits online and trying to connect them, and they don't do their flares correct or something, and they're leaking out refrigerant into the atmosphere. And their intentions were good. They wanted to save the environment, get off of fossil fuels, put in a mini split heat pump, and then they leaked all the refrigerant. Now you just did 10 times worse by letting that happen. So there's a give and take to everything, I guess.
So you thought this was about electrification. This is really a philosophy class.
Yeah.
All right, I think we've covered the
Nancy
gist
has a
of most of
question.
the questions online, but if someone feels like their topic didn't get a sufficient answer, just go ahead and raise your hand now and we'll get to you.
Yeah,
Nancy?
Nancy?
No, I just I just wanted to add just an anecdote that I share with people a lot, but my older son lives in Lisbon, Portugal, and they're in the middle of an enormous housing crisis. They build a lot of not very up to standard housing right after World War II, and now it's all falling apart. So he's lived in several apartments, to make a long story short. And it's clear that whether you renovate or whether you're building a new apartment building in Lisbon, everything is electric. You get, you get an induction cooktop. You get, and his story was he only had one pan and he put it on the cooktop, and of course it was an aluminum pan. And my new stove doesn't work, he said. But the world is going this way, and we need to do, just to Melissa's point, and thank you for bringing that up, Melissa, that we really do need to work on this more and start changing the way people think about this stuff and changing the housing codes as much as possible. If they can do it in a poor country like Portugal, we can do it. That's all.
Absolutely.
Great point.
Thank you. Anyone else?
Well, thank you, everybody. If we have time for one or two more questions, but I think we've thrown an awful lot of information out.
Yeah.
So one of the ways to get a review of some of this information is to go to some of the websites that are in the chat. And also, I want to plug the 350 New Mexico website, Electrify New Mexico, which Steffi has been working at very intensely for, I don't know, a year, 2 years. It's quite an amazing resource. So you may have heard enough tonight to make our website make a little more sense, but it is complicated. It can be, and but with a little work, you can make it happen. And of course, what's propelling us all forward is the egregious impact of natural gas, also known as methane, on the environment. So right now, and people look at me like I'm crazy, but CO2, carbon dioxide, is not the issue in terms of climate gas. It's all about methane because we are in a time crunch. Methane is much 80 over or more than 80 times the impact of carbon dioxide, which I'm sure most everybody has heard that before. And so we need to slow down methane pollution. And 350 New Mexico is going to be working very hard in the upcoming legislature to stiffen the state regulation of methane emissions. But the other way is to do it by all of us getting rid of our gas meter. And our gas, we can't leak methane in our homes And we can't be responsible for the terrible front end of the methane cycle if we don't have a gas meter. The other thing, which probably someone mentioned, is you get rid of gas, especially in your kitchen. Your indoor air quality is importantly better. And when I put an induction stove in, I really didn't think I would notice the difference, but I certainly do. And someone in my household has lung cancer, and she never was a smoker, so I'm not sure. But the stuff that comes out off from a gas stove is nasty, and the little pretty blue flame is more industry spin. So that's another the health benefits
Absolutely.
for our home and our planet are importantly better. So I want to thank Carl and Steffi and Tom for stepping in tonight and giving this. And I want to thank all of you for being here. This wouldn't work without you being here. And next month, we're going to have a little bit different kind of speaker series. We're going to have a photographer, and she is going to show us images and videos about climate that she's been taking around the world for a number of years. So that will be on October 28th, and we'll see you then.
Thank you, everybody.
Thanks,
Thank you.
everyone.